Hello wonderful person, this is Anton and this is Earth, and we're inside the galaxy of Milky Way. In today's video, I actually wanted to answer a simple question. What if one day our solar system accidentally travels too close to the central black hole known as Sagittarius A star and basically passes by within a few thousand or possibly within a few million kilometers of it? Let's find out what happens to our solar system and to our planet Earth. Welcome to What the Math. And I think to start this simulation, what we're going to do is we're going to first create the central region where the central black hole is located. Now, I've talked about what this might look like in one of the previous videos, but basically here we have the central black hole. That's about 4.3 million masses of the sun. And then we're going to basically place a bunch of random stars in orbit around it. Now, these actually do have very specific names. There's a few stars that we've discussed in that video I did previously where we recreated the system. But here, just for the sakes of time, I'm going to just randomly create a few of them just so that we actually have them in orbit. As you can see, some of them are already falling apart because of the tidal effects, but that's okay. We're also going to place a few smaller black holes because we've recently discovered that there is up to about 10,000 smaller black holes orbiting around Sagittarius A star in a relatively close proximity of it. And so we're just going to place a few just so they're located somewhere there. And there you go. So this is the central region of our galaxy. We're not going to try to put too much stuff just because we don't want the game to be too slow. And now let's go into the stars here and choose our sun. And what we're going to do is we're going to assume that maybe sometime in the future, millions of years in the future, by some unknown accident, our sun gets nudged through from its actual orbit and basically approaches relatively close to the central black hole. Now, it's not impossible. It's actually something that may occur if there is enough mass that sort of influences the orbit of our sun. And because Sun has already orbited Sagittarius A star approximately 25 times in the last few billion years, basically here, maybe, just maybe, one day it will actually approach this relatively close. But let's find out what happens if it actually basically plunges through this central region right here, relatively close to the black hole, but not exactly into it. And basically, let's discover what happens to our solar system and specifically our planet Earth. So I'm going to launch the sun, or actually I'm going to launch the whole system with all of the planets and all of the moons, everything coming toward the central region starting now. So there it is. There is our sun, there is the Neptune and other planets, and we can even take a look at the orbits here. And as you can see, almost right away, the orbits get really stretched. Now, maybe I should have done this from a slightly further away distance. Let's actually do this again. I'm going to erase this and come a little bit farther away and do this again from a farther away distance, just so that at least we have some of the stuff, such as orbits, slightly more visible. So here, the orbits, due to the tidal effects of the black hole, get stretched almost right away. Now, I'm actually going to erase some of the moons that are here because they're going to slow down my game dramatically. So all of the moons of Jupiter and all of the other gas giants are basically going to be erased from the simulation just for the sakes of maintaining speed that I need to make this simulation manageable. So we're going to just go in here, select all of them at once, and then go in the middle and click on the planet so that only the planet remains. But I think we're going to keep our own moon just because we want to see how its orbit changes as well. So let's actually just remove all of this and see if we can run the simulation a little bit just to see what starts happening. So because we're still relatively close to the sun, nothing really changes on Earth. It's still going to be very habitable. There's still going to be good enough temperature, and the sun is still somewhere out there. But because if you actually look at this from the top here, because Sun is slightly closer to the black hole than Earth is, it's actually going to start accelerating toward the black hole a lot faster. Mars is even closer, so it's going to accelerate even faster. And what this means is that Sun is actually going to start moving away from Earth. Actually, all of these planets will start approaching the central black hole at a different velocity. And this is due to the different strengths of the gravitational pull at different points. So right here and right here, the effects are dramatically different. Earth receives a lot less gravitational effect than the Sun does. So if I actually zoom into Earth again, and I go under motion here, you'll see that the distance to the star is increasing really fast. We're basically moving away from the star at a ridiculously high speed. We're already at a distance more farther away than Mars is from the Sun, and it just keeps increasing because Sun is essentially being attracted to the central black hole really quickly. And here, this is also sort of affecting the actual shape of our planet. So the pull right here is a lot stronger than the pull right here. So this means that our Earth will start becoming stretched. It's going to become sort of elongated and become egg-shaped, and all of this can actually be analyzed using this value right here known as tidal stress magnitude. Now, as soon as this value becomes more than 1, our Earth will no longer be able to maintain its shape and start losing its consistency. It's actually going to start becoming basically an asteroid belt. It's going to fall apart into little pieces. But we're going to run this for, I guess, a few years until these planets and, of course, our Sun approach the central black hole. But essentially, even within a few days, the entire solar system is completely destroyed. It's basically isolated, and all of these planets become attracted to the central black hole, and their orbits are now completely different. And because the Sun is so far away from our planet, we now get a lot different climate here. Specifically, basically everything becomes really cold. The snow starts advancing into Africa. It basically means that we now have reached a new ice age, and this will actually last for quite a long time until we reach the actual central part of the central black hole, because there are other stars there that might be able to warm us up. But until we get there, we're going to be very cold because our Sun is actually flying away from us, and we can find out at what speed. So if I were to go down here under motion, I would see that my current velocity is 42.1 kilometers per second. I guess it's already 42.2. If I were to look at the Sun, its velocity is at 264 kilometers per second. It's already moving a lot faster, and it's also accelerating a lot faster than our Earth. So it's going to move away farther and farther away from us, and this means that our heat source is slowly disappearing, and the entire planet is soon going to be covered completely in ice. Now, if we're still present on this planet, I guess we might have to start building underground cities with essentially heat sources somewhere underneath on the inside. But you know what? I'm not even sure if we'll be alive by then, because this is millions of years in the future, when Sun one day makes it to the central region of the galaxy, or possibly even billions of years in the future. For all we know, human race by then does not exist. Now I'm going to accelerate this a little bit just so that we can advance time, and we're going to approach Sagittarius A star a little bit closer. As you can see, all of the planets are now basically directly dependent on it. They're not dependent on the Sun anymore, and even the Sun is basically being dragged toward it very fast. I'm not sure if anything will collide with it, with the central black hole, but it's very likely that at least a few of these planets will actually get completely eliminated and annihilated. And it's been a year now since I started the simulation, and we're still kind of far away from the central region, but let's just take a look at what's happening with, well, I guess let's start with some of the other planets. And I guess here, Jupiter and other gas giants will not really look that different, but I'm kind of curious about Mars, Venus, and also Earth. So starting with Mars, which seems to be a little bit more red than usual actually, not sure why, but possibly because of the other stars. And what we can see is that the temperature has decreased just a little bit. It's moving toward the black hole at a velocity of about 470 kilometers per second, but other than that, it seems to be just kind of what it used to be, very similar to what it was like before. How about Venus? Has Venus actually cooled down a little bit? And the answer to that is yes. It's actually surprisingly very cool. I don't know how it got so cool, but I guess it's because the sun has disappeared from its vicinity and it's now been sort of losing a lot of the temperature and releasing a lot of the heat that used to be on the inside into the outer space. So now Venus may actually even be terraformable because it is kind of far away enough from the sun and doesn't receive as much temperature. Which also means that because Earth has completely basically frozen over, this is Earth, we might need to move to Venus because it might be a little bit, oh actually no, never mind. This is still a little bit hotter than Venus. But yeah, Venus might be a potential target for our new existence, and we might need to move there if this ever happens. Alright, so let's run this a little bit more, but actually before I start running the simulation again at a higher velocity, I just wanted to mention that because this is millions of years in the future, all of the continents will look very different as well. The plate tectonics will actually move all of these continents around, so the face of Earth will be very different from what you see right here. This is not very realistic, but since we don't have an ability to move the plates in this game, we might have to just ignore this fact. Alright, let's skip another year and see what happens. Now, after 2 years, Sun is actually significantly farther away from everything in our solar system, and as you can see, it's moving a lot faster than the other planets. You can kind of see it better if I were to zoom in on the Sun. And from this angle right here, you may notice that the other planets are basically dragging behind it, where Sun is moving really, really fast toward the central region. So let's wait until all of these objects actually make it to the central black hole. And after this, we'll see what actually happens to each one of them, but specifically our planet Earth, which is somewhere in the back behind everyone else. Now, after about 3 years, you can kind of see we're approaching the central region relatively quickly. I'm going to take a look at the velocity in a second, but it's getting closer and closer to us. So let's look at the velocity of the Sun here, and it's basically over 3,600 kilometers per second, which is like about 100th, or I guess 1/80th of the speed of light. And it is actually increasing really fast, so you might even reach higher velocity. So the Sun is going to be the first object to approach the central black hole and the central region, and it might even collide with the black hole. So let's see if it actually does happen. I've run this simulation previously, and Sun does seem to disappear somewhere. It possibly gets a collision with the Sagittarius A star. But some of the planets don't. Some of the planets actually do survive. So we'll see what happens here in a few more months. Now from this angle, this looks really, really cool. I'm going to slow this down a little bit. You get these really beautiful stars. Oh, no, there we go. It actually exploded. You got these really beautiful stars, and it's almost like fireflies orbiting around the central black hole. And so what happened to the Sun is that it actually did sort of scratch the surface of the event horizon and lost a lot of its mass, but it still is around. It's only about 25% of its original mass, but it survived. Now this actually does happen in real life, where some stars sort of graze the central or a supermassive black hole sometimes, and they release a lot of these materials, and some of these materials get into the accretion disk of the central massive black hole, and then are released through these two energetic particle jets that are usually pointing away in two separate directions, which is often how various quasars and blazars are created. But anyway, let's go to the first planet that is going to come close to the central region here, and I think the first planet is going to be Mercury, because it was the closest to the Sun. And similar to the Sun previously, the velocity here is suddenly dramatically jumping up to about 20,000 kilometers per second. But I'm going to actually go into this setting right here, because I want to see the tidal effect. So you can see the tidal stress magnitude right here, and as soon as this reaches 1, it's very likely that Mercury is going to start falling apart into little pieces. And let's see if this actually happens. So we're going to wait a little bit more. And as we're getting closer and closer, you'll notice that things start increasing quite dramatically. So tidal stress magnitude is increasing. That means that Mercury is now going to get really, really stretched. It's going to basically kind of get spaghettified, but not to the extreme effects of what you would expect from a smaller black hole. And also, because there are so many stars here, you will also get a lot of various illumination from various stars. And there you go. So that was actually Mercury passing relatively close to the central black hole. It kind of grazed it as well and is now moving away from it. So it basically lost some of its mass and is moving away at the speed of about 36,000 kilometers per second. Now I'm going to try to do this again, but this time a little bit slower with the next planet here, which I guess is going to be the gas giant Neptune. Now this might be actually very interesting, so let's see what happens here. And interestingly, the surface of Neptune is extremely bright right now. The temperature is actually increasing dramatically as well. It's going really fast up, but it's mostly because of the tidal effect. So it's basically being stretched to the point where the tidal heating effects are ridiculously high. And it's really because of all of this really high gravity that's essentially produced by the central black hole that's right there. You can actually even see it from here. Now, what is the distance to the central black hole? And it says here that the distance is just over 10 astronomical units, which is kind of realistic in terms of the distance to the sun from Neptune. And it's coming closer and closer. We're going to slow down in a second just so we can see what actually happens when it gets really close to the central black hole here. And right around now, when the tidal stress magnitude gets to about 1, we'll see how Neptune might actually fall into little pieces. Or it might actually, it might actually collide with the central black hole, because it looks like it's going straight for it. So there we go. The tidal magnitude is at 30. You'll actually see all of this falling apart in a few seconds, and then it's probably going to combine into the central supermassive black hole. And just to give you an idea of how fast we're actually moving, this is going to be in real time. And we're actually moving at about half of the speed of light right now. Very fast. You can see the central black hole right in front of you. This is a huge object right here. This is the event horizon of the central massive black hole. And Neptune is unfortunately going to be falling apart into little pieces. So there's a lot of fragments coming off the surface, and that's because of various forces acting on various parts of the Neptune here, and essentially spaghettifying it and stretching it and making it suffer quite dramatically. Alright, so let's accelerate this about 5 times and see what actually happens to poor Neptune. That's possibly going to basically smack right in the middle of this object. And there we go. Neptune has been swallowed by the black hole. Now, whether this happens to Earth or not, I'm not actually sure, but let's find out by waiting for, I guess, a few more years and just kind of seeing what happens to these other planets. As you can see, Mercury has already left. It became what's known as a rogue planet, basically a planet without any star. Our sun became actually a red dwarf. This is a type of a star that will live for a very long time, possibly even trillions of years. And the other planets might also become rogue planets or combine with Sagittarius A star. And also our moon has left us for some unknown reason. And there goes the Saturn. It also became a rogue planet, moving at a very high velocity, half of the speed of light away from the system. And something completely different happened to Jupiter. It actually turned into a very tiny rock that's only about 137 meters in radius. I think the central black hole actually swallowed most of its mass. So now it's this smoking rock in the middle of space, which is very unusual and very unexpected. Okay, so how about Earth? And Earth seems to be approaching the Sagittarius A star at a slight angle here, so it might still get influenced by these other bodies, but it's very likely that it might be able to survive all of this ordeal and not be destroyed like the other planets, or might even stay in orbit around Sagittarius A. So let's actually slow down the time here and go through this simulation in a little bit more detail as our beautiful planet approaches this somewhat scary and dangerous region. First of all, we're still living in Ice Age. It's been about 4 years and something like 2 months We're basically living on a nice planet, ice ball, that has no source of energy. But suddenly there's all these other stars in the region that might start illuminating our planet and create a bit of sort of light and also a bit of energy for us. So maybe the humanity that used to live under this ice sheet will actually come out and get to witness this incredible view of various stars and various black holes orbiting around the central region. So basically, they might see this incredible view of the dance of the fireflies, as I call it. And if I actually stand on the surface of our planet by pressing C button, you can kind of see what they might even observe in the sky. These stars moving at very, very fast velocity. Sagittarius A is right there. You can kind of even see the outline of it. And all of this looks absolutely, absolutely incredible. So this is what we might see if we actually approach the central region. And as we're approaching the central black hole, this is what our beautiful planet now looks like. It's essentially one big snowball illuminated by many different stars around it. So basically we have daylight pretty much everywhere, but the temperature here is still pretty cold because it hasn't really spent enough time being warmed up by various stars. And where exactly is the central black hole? Well, it's actually right there. This is how close we are to it. And basically here, at this point, this is where the tidal effects might be strong enough for our planet to start losing materials. We're going to go into tidal stress here. You can see it's at almost at 0.1, and it's still increasing. If it ever reaches 1, this is when we start losing things. But right now, what our planet is experiencing is ridiculously strong tsunamis, a lot of earthquakes, and a lot of volcanoes going off everywhere because the strength of this tidal force is ridiculously strong. On top of that, we're also moving really, really fast right now. Our actual speed is 60,000 kilometers per second. This is when you get to witness or start noticing relativistic effects. Basically, if anyone was outside of our planet Earth, they would see us moving in slow motion, where it would actually move slightly slower than usual. So basically, we're now living in a time machine. We're going into the future, and a lot of the things on our planet are slowed down. But let's actually see if anything gets ripped apart by the tidal forces, which are now at about 0.55. This is really, really, really strong. And it only took a few moments for us to get to over 1 magnitude of tidal stress. Now, nothing is flying off the planet just yet, but this white, beautiful ball that's basically illuminated by other stars might actually start feeling the stress really soon. I would not be surprised if this is when we start losing our rocks and our ice sheets, and basically people that might accidentally travel to the surface of the planet. Although surprisingly, nothing really flew away, nothing really happened. I think it's maybe because we did this a little bit too fast, but looks like our planet survived and is going to come out of this situation completely unharmed. Although the climate here is still pretty cold, the actual temperature is very, very low, and we're still living in the ice ball Earth. Now at this point, I think we're actually flying away from Sagittarius A star, and I think we might actually be in orbit around it. Oh, that's right. We have achieved an orbit, a very, very elliptical orbit around Sagittarius A star, which means that our planet will now stay here forever. Or I guess for as long as something doesn't disturb this orbit or destroys our planet. Now let's see what happens after a few more years. We're going to run the simulation a little bit longer and discover what happens to both the surface temperature and also the actual shape of our planet. And looks like something happened to our moon. Our moon traveled a little bit too close to Sagittarius A and has been basically destroyed. It turned into dust and fragments. And less than half a year later, we're approaching for our second orbit here, our second periapsis of Sagittarius A, and basically looks like we've achieved a stable orbit around it. So this is going to be our life from now on. Extreme tidal effect, a lot of stars in our skies, and a lot of dangers of living next to a central black hole. And that's essentially, oh, also that happens apparently, we do lose some rocks. Yeah, well that at least will warm up our planet. And anyway, so hopefully now you know what would happen if our solar system approached the central black hole relatively close, and what would basically occur to both our planet and our solar system. Now, everything here basically got either destroyed or completely kicked out of the system, with Jupiter being the worst victim, or I guess Neptune, because Neptune got swallowed, but Jupiter became a tiny rock. Saturn experienced some kind of a collision and also became extremely hot as well. And Mars, Venus, and Mercury became rogue planets, being kicked out of the solar system and essentially started being their own bodies, their own little systems. Not entirely sure what happened to Uranus, but I'm guessing it got swallowed as well. Our sun became a red dwarf, so it will actually live for a very, very long time, possibly up to 1 trillion years now, and will not become a white dwarf for a very, very long period of time. And lastly, our planet Earth, our own home. And I guess this is the future of our own planet Earth. Basically, it received a few collisions from its own materials. It became an ice world, covered entirely in ice. It also has quite a lot of starlight and sunlight from various stars in the skies that are orbiting around the central black hole. And it experienced quite a lot of tidal effects, including underground tsunamis, earthquakes, volcanoes, and a lot of other stuff. In other words, it's not a very pleasant world to live on. But you know what? That's all I wanted to show you in this video, and hopefully you enjoyed watching it. And if you did, don't forget to subscribe, like this video, share it with your friends, and come back here tomorrow to learn something else. I'll see you tomorrow. Game you later. Bye-bye.